Now you are ready to learn about the winds, and winds then drive the ocean currents, and heat and energy gets moved around by the winds and the evaporation clouds, ocean currents, and so on. So first, let's look at the structure of the atmosphere. What does it mean? You're already aware that the temperatures are warmer near the surface. As you go up in the atmosphere, it gets colder. If you climb the mountain, you know that it begins to get cooler, and you begin to feel maybe some uh, difficulty in breathing, as if oxygen is reducing. It really depends on how high you go, but this can happen, of course. Or if you've been on an airplane, you know that they seal all the doors and windows and keep the airplane pressurized inside, because the pressure outside is very low. So the pressure also decreases from the surface to the upper atmosphere, or as you go away from the surface into the atmosphere above, right? On the other hand, the ocean has pressure increasing as you go deeper, because as with each 10 meters you add so much more water on top of you. If you keep diving deeper, water is very heavy, so every 10 meters you get another atmosphere worth of pressure on you, whereas pressure in the atmosphere keeps dropping as you go above, right? So all these things matter. Temperature decreasing with height will not decrease all the way out to where the satellites are flying, for example. At some point, there is formation of ozone in the upper atmosphere, and ozone formation actually traps energy in the UV ultraviolet radiation, and that warms the atmosphere. So we have the troposphere in the lower level. Troposphere ends at the tropopause, and then you get something called the stratosphere. So troposphere cools from the surface to the tropopause, and then the temperatures warm. So listen to the podcast, it's real fun. We'll keep adding more and more details of the circulation, because without circulation we cannot do weather and climate change, okay?